Here comes the exciting part. So we want to also now merge transportation, which is, as we have mentioned several times in previous chapters, one of the big emitting sectors, as well as a recalcitrant one in terms of trying to reduce its emissions. So if we make it part of the energy production and distribution system by converting the fleet of transportation into electric vehicles and fuel cell electric vehicles, then maybe there is a way to go really big on bringing down greenhouse gases uh, and the criteria pollutants, right? So merging transportation then should include fuel cell electric vehicles, plug-in electric vehicles. We already talked about battery electric vehicles which go into here. So that brings in the idea of either supplying fuel directly to the car like hydrogen, or the battery technology so that it needs to plug in. And there can be a combination where for shorter distances the plug-in electric battery works, and for longer distances the fuel cell electric vehicles fuel cell can work to drive the engine. Hydrogen is much more energy dense and obviously non-polluting, but it can take you much longer distance than a fossil fuel. Okay, so that those kind of mergers are possible as well. So examples of plug-in electric vehicles are the battery electric vehicles, and plug-in fuel cell electric vehicles. So alternative vehicles are designed to operate on fuels that portend a potential of zero emissions of both greenhouse gases and criteria pollutants. Obviously, that's what we want. And secondly, an opportunity to be generated locally and thereby achieve the goal of fuel independence, or even within the country reduce the fuel transportation and losses involved in loading and unloading fuels. Okay. Secondly, alternative vehicles have no tailpipe emissions. Obviously, that's the goal of carbon or criteria pollutants. The greenhouse gas and criteria pollutant emissions, if any, come solely from the fuel supply chain, such as the generation of electricity or production of hydrogen itself. Electricity and hydrogen are the two fuels emerging to power alternative vehicles. So you can, this is what I meant earlier when we said we keep moving the emissions to down the chain, so the car itself can become completely free of tailpipe emissions, but it's running on batteries that are either fuel cell or electrical batteries. So the production of fuel for the fuel cells or electricity for the battery can still be polluting. So it's removed from the vehicle itself, but still something that cannot be ignored. So electricity as a fuel then still looks like this, and it's still not net zero carbon as we have set up this way here. So the same figure, lovely. So looking at central generation and distributed generation, with our users being industry, commercial, hospital, university, and residents, with our combination of distributed power generation members with storage along the way, and you have renewable source of fuel here with the Tiger station, but you have now added the transportation in there. Each one is a some sort of a fuel cell or a battery electric vehicle, plug-in battery, plug-in fuel cell, or plug-in electrical battery, and so on. So it's beautiful that the same figure can be used to add these sorts of details, which we will continue to do. Okay, so hydrogen generation market by region has grown over the last few years and is projected to grow in the coming years out to 2023 from this website here, Markets and Markets. North America, Asia Pacific, Europe, Middle East, South America, and Africa. And again, Asia dominates here, of course, because of China, but India has bold plans, ambitious plans to go electrical as well. But obviously the problems we've been talking about in terms of distributed generation and grids to deal with, which we will look at some more. And the storage has a long way to go in countries like India, or even in the countries in countries like US or continents like Europe, because only California is way out ahead of everybody else. Okay, so here is the reference of $135.5 billion going up to whatever, a couple of $100 billion by 2023 projected value. So electrolytic zero carbon H2, we already talked about it in pathway 2. Electrolysis is producing H2, it is pipelined or is being pumped into natural gas, with biogas also adding renewable hydrogen here. And now you have added hydrogen fuel cell cars or plug-in electrical vehicles, and you have distribution of hydrogen as a source to the Tiger stations, as well as stationary fuel cells, which are going to help the power load here in various users. So you still have fossil fuel here, so you're still not zero carbon, but you have added the fleets of battery and fuel cell vehicles. So curtailed renewable resources, that's why it's put here near solar and wind, are proposed to be used for electrolysis to produce zero carbon hydrogen, which you can call renewable hydrogen, and including ideas like biogas and trigeneration with electricity, heat and hydrogen. Going back to the deployment of hydrogen fueling stations in 2019 in California, there is the Northern California and the Southern California. Lovely, right? So California is really the living laboratory and an example for the country and for the world in terms of the renewable technologies, distributed generation, storage, merging transportation into electricity and electricity production and distribution, and increasing the fleet of vehicles to be emission free. Okay, so always have the good living examples so that others can go watch and learn. This also works for some climate adaptation examples for some cities on the coast in Germany. For example, have taken engineering solutions to manage sea level rise and coastal erosion, which you can go and watch, and then you can come back and try to engineer it for your backyard, like in North Carolina or Florida or Gulf of Mexico and so on.